First thing to note, your unit exam is this Thursday. If we follow the timeline of the course, we actually have one more section to cover than we are going to cover for this unit, which would put the unit exam on Tuesday of next week, which is not what we want to do. We don't want to have a 4-day weekend and then have you come back and write an exam. So this unit actually covers sections 1.1 to 1.5, but we're not going to do 1.5 before we write the exam. So when you write the exam on Thursday, it will just cover everything up to and including what we do today. And then when we come back next week, after you've written the exam, we're going to finish off the unit by doing one section. And that section 1.5, I haven't quite decided yet. It could be that I'm going to evaluate you by using an assignment or a quiz, or it might just be that I put the few questions relating to that on the next unit exam. I haven't decided. But anyway, that's what's going on. So that's on Thursday. Because our exam is right after lunch, you may start the exam early at 12:15. So at 12:15, the exams will be on the desks in this room, and if you wish to start at that point in time, you can. You do not get extra time past the bell, though. Okay, so that's the cushion room, and that's more than fair. I always tell students, particularly at the beginning of a course, before they write their first exam, for most situations, if you get to the end of the period and you are not done, in 99.9% of the situations, that's because you're not ready for the exam. It isn't because you need extra time. You need extra time because you need to put more effort into preparing for the exam. The idea with an exam is you look at the first question, you read it, and you go, okay, I know what to do. If there are, let's say, 18 multiple choice and numerical response questions and one written response question, and every time you get to a question, you have to go, oh, what was that about again? How did that work? If you have to do that for every question you read, of course you're not going to have enough time. But that isn't a problem with your abilities most of the time, or your thought processes. It's a problem with lack of preparation. Okay? If, however, you do have accommodations for extra time, you need to send me an email, please, in the next day or two so that I can make arrangements for that to happen. You don't need to send me an email every time we have an exam, but I need to compile a list of people who get extra time. That extra time is double time for an accommodation, and it's in the Learning Common. I'm not trying to dissuade anybody from doing that if that's what you do, but in the Learning Common, it's not necessarily, I'll be honest, it's not necessarily the most ideal exam situation room. There's a lot of talking most of the time. People are coming and going. It's not a room that you can really focus as well in. And remember that assignment number 1 is due tomorrow at the beginning of class. Okay, so hopefully you've had enough time to work on it. Brief discussion of that assignment. And I had this discussion this morning and over the weekend with some of you. An explanation is not a narrative. A narrative is a step-by-step description of everything that's going on. So, saying in words, I subtracted 3 from both sides is not an explanation. I'm not interested in that kind of stuff. I'm interested in if you develop an equation that you explain where that equation comes from, what your thought process is. Once you've established an algebraic statement, say an equation, you don't need to explain the steps that you use in solving that equation. That's not what an explanation is. I gave an analogy this morning, and it's one that I very often use. It's like you asking for my recipe for cheesecake. And the very first item on the list says, wash your hands. And the second item says, walk to the cupboard. And then the third item says, open the cupboard door. Man, you don't want to hear all that. You want to hear, beat 4 blocks of cream cheese in a bowl until smooth. That's what you want to hear. You don't need to be told all these little details in excruciating detail. Okay, so be careful that you understand the difference between an explanation and a description. A description is describing what you're doing. An explanation is why you're doing what you're doing, and that's more important. Anyway, let's take a look now at your work from, this is actually from Tuesday. We learned about this formula. A geometric sequence is one in which there's a common ratio. The common ratio is what you multiply by to move forward in the sequence, or it's what you get if you divide a term by the previous term. And we were looking at some applications. We had lots of practice with this the day before our last class, which would have been Tuesday of last week. And then our last class dealt with applications. And I know that many of you have asked me to go through number 9. And I did not assign A or B. And the reason for that is there are 2 different sets of answers you can have for A or B. One is the set of answers where you call that initial height 3 meters the first height or the first term. And as I've told you, I would rather call this, height that I'm going to indicate T1, because then T1 is the height it reaches after the first bounce. T2 is the height after the second bounce. T3 is the height after the fourth bounce. So we'll get to the specifics of C and D in a second, but this is how I would set it up. I would say T1 is, now I have to do a calculation here. You're going to do it for me, actually. That it's dropped from 3 meters and it rises to 75% of that. So we need to know what 75% of 3 is. And I'm pretty sure I know what it is, but you're going to do the calculation just to make sure that I'm right. So I'd like to know what 75% of 3 is. Jay? And that's what I get, 2.25. I don't need to, if you truly understand what's going on here, I don't need to find the second term. I need to understand that the second term is 75% of the first term. And the third term would be 75% of the second term. In other words, the common ratio is 0.75. So I get T sub n equals 2.25 times 0.75 raised to the n minus 1. And I've set this up in such a way so that if I use n equals 1, I will be getting the height after the first bounce. If I use n equals 3, I'll be getting the height after the third bounce. I'm consistent here in how I'm thinking of this. So for part C, I simply need to find the sixth term. Speaking of written response, if this were a written response problem, I don't need to explain, well, I probably should have this formula written down if it's a written response. But I don't need to explain anything past this point, the last line that I've written. What I should explain in words is, why is that the first term? And I should show how that calculation was made. I should explain why the common ratio is 0.75. But once I throw them into a formula from the formula sheet, I'm done with explanations. I don't need to explain my algebra. Okay, so let's work this out, and then let's get to the second question here, D, which is more complicated. .25 times 0.75 raised to, I'm just going to say raised to the 5, and I hope everybody is okay with that. And by the way, you certainly wouldn't need to show on a written response how you go from what I have written on the board to this. What's it doing that for? 0.53. Is this in meters? No? I mean, you don't need to explain, because I did see a couple of people's written responses this morning where they did the equivalent of explaining, now I entered into my calculator 2.25. Don't do that. That's not an explanation. Now, after how many bounces will the ball reach a height of approximately 40 centimeters? The only way you can do D, we have T sub n equals 2.25 times 0.75 to the n minus 1. The only way that you can answer this question, first of all, 40 centimeters is 0.4 meters. This equation is set up to work in meters. The only way that you can find this is to put this into your calculator. Well, man, I shouldn't say the only way. The most efficient way that you can find n here is to put that into your calculator for n1, go to your table and start looking at different values of n and seeing how many n's, which are bounces, it takes to get to there. What do we have here? 2.25 times 0.75 raised to, we need to put this exponent in brackets. Otherwise, it will only raise it to the x and then subtract 1, but we want to raise it to whatever x minus 1 is. I set up my table by starting at 1. By the way, with these sequences, when you talk about n is never 0. N always starts at 1, and then it's 2, and then it's 3. So I'm starting at 1 and going up by 1. And I mean, the fact that I think this question says approximately, right? The fact that it says after how many bounces is the height approximately 0.4 meters, I would say the answer is after 7 bounces. Now, if you want to be picky about it, and sometimes in math we do, had the question said, after how many bounces does it take for the ball to reach a height of less than 0.4 meters? The answer would be, I'm suspecting 8. Right? But because it said approximately, it's a little kind of, I don't know, as my mom would say, wishy-washy, not quite clear. I would go with 7. All right, I hope that helps with D. Does anybody have any questions at all from any of the remaining problems that you would like me to go over? All right, we're going to move on today. It should come as no surprise to you that since we've looked at arithmetic sequences, and then we looked at what are called arithmetic series, which is what we get when we add up the terms of an arithmetic sequence, it should come as no surprise to you that since we've studied geometric sequences, we are now going to look at geometric series. And, you know, as I said before with geometric, in many ways, geometric progressions are, I would say, easier to work with because you're not expected to do the math on paper because you don't know about logarithms and exponential laws for these types of situations. We're going to be looking at finding the sum of a geometric series today and basically finding how many terms there must be in a series to give a particular sum. So this is not a long lesson, but it does introduce a couple of new formulas that we need some practice with. A geometric series is simply the sum of the terms of a geometric sequence. And although I don't think it's really that big of a deal, everybody, like functionally speaking, you can get through high school math without knowing things like this. Sometimes on an exam, you are asked about the difference between a sequence and a series. Like those two words mean different things. So you're expected to know, for example, that 2, 4, 8, 16, etc., just with commas, is what we use to describe a particular sequence, whereas the series is 2 plus 4 plus 8, etc. And clearly, I think with a bit of thought, you can see these are both geometric. because there's a common ratio. We're multiplying by something each time, and what we're multiplying by each time is 2. Well, when we learned about adding up arithmetic terms, I showed you how we got the formula. That was when we talked about Euler as a student in elementary school being asked to find the sum of the first 100 natural numbers. And we used that idea to develop a formula. I can't even begin to explain to you at this level why the formula for Sn for geometric is this, but it is. One of the things I want to point out to you, well, we can talk about what's in this formula. T1 is obviously the first term in the series. R is the common ratio. I'm not going to write down what Sn is. You should know what Sn is. It's what Sn was in our arithmetic series formulas. It's the sum of n terms. So if you use n equals 5, you're finding the sum of the first 5 terms. So I will add that to the list. I will say n is the number of terms. And please don't get ahead of me here. Number of terms being added. But I want to write down over here the formula for Tn for geometric. And I want to read this green formula out to you. And I want you to listen carefully to how I read it out. And then I'm going to read the other formula out. The green formula says Tn is T1 times R to the n minus 1. When I look at this formula, Sn is T1 times, in brackets, listen to how I say the next part, R to the n minus 1. When I talked about that over here in the green formula, I say R to the n minus 1. In the green formula, n minus 1 is the exponent. We're figuring out what n minus 1 is and then raising R to that exponent. In the new formula that's dead center in the middle of the screen here, that in brackets on the top is R to the n minus 1. It's taking 1 away from R to the n. It's not taking 1 away from n and then using that as an exponent. So this bit of business over here where I made a big deal of saying, well, I have to put that x minus 1 in brackets, that's because in the green formula, which is what's being used on the computer screen here, on the calculator screen, in that green formula, n minus 1 is the entire exponent. It's in brackets. And I say that, and I'm going on and on about it, because some people think it's the same pattern here, that this 1 is part of the exponent. It's not. You calculate R to the n, and then you subtract 1. And the first part of this lesson, really, everybody, is about us using that formula, becoming a little bit more familiar with it, and knowing how to use it on our calculator properly. So determine the sum of the first 13 terms. In example 1, well, it's pretty clear the first term is 6. With not a whole lot of brain power, we can see the common ratio is 2. I think you would agree. And n is 13, and we're finding Sn. So Sn is the first term times R to the n minus 1 over R minus 1. And because this is a fraction, you need to be very careful when you enter a lot of numbers into your calculator at once. And my recommendation with fractions, although we won't need to here, is you calculate the top and you calculate the bottom, then you worry about dividing them. When you go to enter this as one thing, it becomes problematic at times. But let's write down what this is going to look like. S13 equals the first term times the common ratio raised to the n, which is 2 to the 13, then minus 1. And by the way, when I write that, I leave a lot of space between the 2 to the 13 and the minus 1 to really highlight the fact that we're subtracting 1 from 2 to the 13. And this is over, in brackets, 2 minus 1. And I said that this shouldn't be a problem on your calculator because 2 minus 1 is 1. And what I would highly recommend is not just blindly entering stuff into your calculator. Look at what you're about to enter. Do you really need your calculator to enter 2 minus 1? No, this is 1. And to drive that point home, this is what it simplifies to. Let's not worry about the numerical answer just yet. This is what it simplifies to. And I could easily make this on an exam a numerical response question and say to you, S13 is A times B to the 13 minus C. And ask you for the values of A, B, and C. And you can see by comparison that we have 6 times 2 to the 13 minus 1. So you would enter 6 is A, 2 is B, 1 is C. The negative's already there. So sometimes on an exam, I'm not interested so much in the numerical answer. I'm interested in testing to see if you know how to get there. Anyway, we can certainly calculate this. From my home screen, 6, well, I'm going to do it in 2 ways. I'm going to do it the way I would have been taught to use a calculator when I was in, say, grade 9, when we were first allowed to use a calculator. I would have been taught to take 2 raised to the 13 and hit enter. Then I would have been taught to subtract 1 from it and hit enter. Then I would have been taught to multiply that by 6. So here is the answer. Of course, if you want to enter it all at once, you can go 6 times in brackets, 2 raised to the 13 minus 1. My calculator knows that since I didn't put the 13 minus 1 in brackets, it means 2 to the 13, then minus 1. And I get the same answer. So the answer is 49,146. And one of the things that you will discover, is that what I just saw? 4-6, not 3-6? To fix that, 49,146. Okay. One of the things you hopefully have learned already about geometric, and we talked about this extensively last week, is they grow quite rapidly. You remember when I talked about the penny on the first day and double and double and double? Let's imagine that it was March, which has 31 days, and I don't want to know how much money you get on the 31st day. I want to know how much money you get in total. I mean, the first term is 1 penny. The common ratio is 2. And we talked about the fact that the general term is that. So if I put 31 in there, that's how much money I get on the 31st day. I don't think we did it this way. That's going to get annoying. But let's just find the 31st term of this sequence. It's going to be 2 raised to the 30. To the 30. Because I'm going to put 31 in for n, and 31 minus 1 is 30. This is that number. Remember, I don't know if you remember, but I said it was a little over 10 point something million dollars on the 31st day. Which, by the way, means on the day before, you'd get 5 million. Half of that. If we wanted to know the sum then we would take the first term times r to the n, then minus 1 over r minus 1. This would be 1 times 2 to the 31 minus 1 over 2 minus 1. Let's figure out what this is. How much money would I get in total? Not just on the 31st day, but in total. Well, again, we're dealing with that 2 minus 1 on the bottom. So we don't need to worry about it. 2 minus 1 is 1. 1 on the top is just 1 times what's in brackets. So 2 raised to the 31. And then subtract 1. Well, I mean, I don't think we really care that you're subtracting a penny in the big scheme of things. But if we subtract 1, we're getting over $21 million in total. So geometric sequences in series grow quite rapidly. Let's take a look at another example. Find the sum of this series. Okay. Well, Sn equals the first term times the common ratio to n, the number of terms we're adding, then minus 1. Well, I've really exaggerated that spacing, haven't I? So r to the n minus 1 down the line over r minus 1 I mean, this still has a first term of 6 and it has a common ratio of 2. It's just that, wait a minute, what's n? We don't know, right? So how are you going to find n? Well, you're going to use this. Tn equals T1 times r to the n minus 1, which means Tn equals 6 times 2 to the n minus 1, and we are trying to determine the following. How do you determine n that will give Tn equals 384? Well, let me write that down. We're trying to solve this formula, or this equation rather. 384 equals 6 times 2 to the n minus 1. What's the only way you know how to solve that? Wow, what's the only way I've taught you how to solve that? Remember to use your hands. Yeah. Table. Yeah, set up a table. You just don't have, you haven't been taught how to rearrange this for an exponent. So, back before we had these calculators, which was before you were born, and I were teaching this to a group of students, I would say, we're going to have to do this by trial and error. You're going to have to put a number in for n like 6 and see if you end up with 384. And if you don't, try 5. And if that doesn't work, try a different number. But with this technology, and it isn't, magical, but it's a pretty cool tool to have that table, that you can generate a table of values if you know the equation that is used relating the columns. I can put 6 times 2 raised to, in brackets, x minus 1. I'm going to start at 1 and go up by 1, and I go to my table. Oh, there it is. It's 7. The value of n that gives 384 is 7, and that means that 384 is the 7th term. And that means that there are 7 terms we're adding, right? If this is T7, then there are 7 terms. And now we can solve this problem. S7 equals the first term times the common ratio to the 7, then minus 1 over 2 minus 1. Go ahead and figure out what that's going to equal. I'm going to say 762. 762? So make sure that everybody, you were able to get 762. I think sometimes using basic math facts is simpler. Like, I happen to know what 2 to the 7 is. It's 128, but you probably don't. Just take 2 to the 7, then subtract 1. You don't have to do it all in one shot. Then multiply by 6, then divide by 1 if you like, because we're dividing by 2 minus 1. Now, I want to pull up your formula sheet here to talk about something before we move on. When you look at the formulas for arithmetic sequences and series, there they are. So we have the first formula there, which is the general term formula, and then we have these two series formulas to find the sum of terms. I want you to notice that no matter what, the only way you can find the sum of the terms of an arithmetic series is you need to know the number of terms. N is in both of these formulas. You have to. And when we did problems in the past, sometimes we would have to use this top formula to find out what n is, because no matter which other formula you use, you need to know n. However, we go back to our notes, it turns out there's a second formula for Sn for geometric. And what's interesting, I find it interesting, is you don't need to know what n is. Which is weird. Like, to me, it seems odd that you can calculate the sum of a certain number of terms without knowing how many terms you're actually adding. In this formula, and this is nothing new to you, we talked about this before, Tn is the last term. We need to know that. And the reasoning is, if you're finding Sn, you're adding up the terms to the nth term, so T sub n must be that last term, that nth term. R is clearly the common ratio. T1 is the first term. Now, again, I really wish I could show you where these formulas come from, but it would just be lost on you, and that's not an insult. It's just that the math involved, it would just put you to sleep right away because you wouldn't be able to follow the steps. Number 3 says recalculate the sum that we found in question 2 using this other formula. So let me talk about this other formula first. Sn equals Rtn minus 1 over R minus 1. Did I write it down correctly? I didn't. Minus Tn, rather. Did I write it down correctly this time, Leah? Okay. So there's my formula. There are no brackets here. It isn't R times Tn minus T1. It's R times Tn, then it's minus T1. So when we put the numbers in, we don't even know what n is. Now, let's face it, we do know what n is, right? It's 7. But imagine we didn't. Imagine we didn't want to do this bit of business on the right-hand side, which was a bit more work, right? Sn would be the common ratio, which is 2, times the last term, which was, is that 384, am I right? Okay. Then minus 1 over R minus 1. Well, go ahead and figure out what that is. You get the same number, or you should, but I'll give you a second to calculate it. Thank you. I keep putting 1 here. This should be 6. Good catch, Aaliyah. Thank you. So make sure if you put your head down after I wrote that and you started banging away on your calculator, make sure you know that I did make a mistake there and I wrote the number 1 in the spot that's highlighted, and I should have written the number 6. As I said to you, it's a short lesson. You'll certainly get some time today to polish up that written response, which is due tomorrow. Was it 762? Was that the number that I remembered? Okay. And can I get just a couple people to confirm? You still get 762. Right. A series given by 2 plus 6 plus 8. We're going to add up a number of terms, but we need to have a sum of 65, 60. How many terms are we adding? When you take a look at both of these formulas, let me write this formula down first. Can I use this formula to answer this question? No, because it doesn't have n in it. I mean, it has n in the Sn and it has n in the Tn, but nowhere is the variable n in there, so I can't solve for n. This is a dead end. However, I can use this. What do I know? I know the first term is 2. I can see the common ratio is 3. And the sum is 65, 60. So I need to load those 3 numbers into that equation wherever I see the corresponding descriptions in terms of parameters or variables. Because, I don't really need to explain this, but I feel the need to because I opened the door. T1 is a parameter. R is a parameter. But S is not a parameter. It's a variable. It depends on how many terms you're adding. Right? Variable, variable. Those are variables. The T1 and the R are parameters. So let's load everything in. 65, 60 equals T1, which was 2, times 3 raised to the n minus 1 over 3 minus 1. It probably is not going to come to as a big shock to you that you don't really know how to solve this algebraically. But just put your calculators down for a second, and I would like to do so with you to a certain point. If you were given this equation, you want to simplify things first. And the fact of the matter is, three minus 1 is 2. Right? That's a lot simpler. This is what we mean by simplify. That's a lot simpler than saying 3 minus 1. Oh, and we have 2 on the top and 2 on the bottom. And there will come a time where those brackets that I put, they're really, really important. And I'm going to explain briefly why they're important right now, but there will come a time where we delve into great detail about it. The reason why you were allowed to, quote, cancel something from the top and the bottom is that thing has to be a factor of the top and a factor of the bottom. What is a factor? Quick lesson here. Is 2 a factor of 12? Yes. Why is 2 a factor of 12? Because 12 can be written as 2 times something else. Times in brackets. Okay. Is 3 a factor of 12? Yeah. Because I can write 12 this way. I can put 3 as something in brackets that is being multiplied by everything else. So these brackets are permission for you to do that. And what we're left with as an idea is a lot simpler than what we had to begin with. But I can come up with an even simpler idea. And it's this. Whoops. That if I add 1 to both sides of that equation, that's an even simpler idea. The idea was that 3 raised to some exponent minus 1 will give you 65, 60. The idea now is 3 raised to an exponent gives you 65, 61. And this is where your skills end. You cannot solve this algebraically, but I would like you, without using a table, to find a number n that you raise 3 to get 65, 61? Like, is it 3 squared? Well, I hope you're not going to try 3 squared, because that's 9. I want to say 8, maybe. Is it 8? So what we're doing here is we're just going through the motions on the calculator and saying 3 to something has to give me 65, 61. And you try maybe 3 to the 7, and you don't get that. And you try 3 to the 8, and you get that. So n is 8. There is an algebraic way to rearrange that for n, but you don't know how. Okay? You'll learn about that about a third of the way through Math 30-1. Of course, there would be nothing stopping you from putting this entire thing in for y1 and going to your table and hunting for 65, 60. I sure hope that you wouldn't put the whole thing in. I hope that you would recognize that this denominator is 2, and maybe even recognize further that that 2 and this 2 cancel, making fewer keystrokes to get the answer. All right, any questions with that example, which was example 4? And the last one. A geometric series has 5 terms and a common ratio of -3. The sum of the series is 10,940. What is the first term? I want to just caution you about something here, though, before we get started. Since a common ratio being negative means the terms go from positive to negative, think about that for a second. If a common ratio is negative, the terms go from being positive to negative to positive to negative. With a geometric series, if you had something, if you had something with a common ratio, say, of 2, what's going to happen is that, right? But if you have something with a common ratio of -2, and, sorry, I can't think and work at the same time. And by the way, I've only put 3 terms here. I could put more. It's just that doubling is quite extreme. So would you agree that that looks like it's probably doubling regularly? Okay. What's going to happen here, though, is if r is -2, is that's going to happen. It's going to keep going up and down across that axis. It's going to get really big in a positive direction, really big in a negative direction, really big in a positive, bigger in a negative. And the reason I mention that is if you start to add these numbers together, the positives and the negatives cancel. So what I'm getting at is when you look at the sum, it's very difficult to wrap your head around what the sum means if you have a negative ratio. What this means in this question is if the sum is positive 10,940, there are more positive terms than there are negative terms. I shouldn't say it that way. The total of the positive terms is greater than the total of the negative terms. I shouldn't say there's more positive. There probably is, but that's not the point. You got a lot of positive terms, you got a lot of negative terms, but the positives are winning. So, I'm going to write down this formula. Sn equals T1 times r to the n minus 1 over r minus 1. Can we use this formula to determine the first term? Well, do we know the common ratio? Yeah, -3. Do we know the first term? Well, we're trying to find the first term, so that's good. Do we know the number of terms? Yeah, 5. Do we know the sum of those 5 terms? Yes. Okay. I think we're good to go. Not to put too fine a point on it because I think you get it, but, and I don't really like using this color, so I won't highlight it, I'll just do that. That is what's going to go here. This number is going to go here. R, whoop, R is going to go there, and it's going to go here. What else do we got? Let's use blue. Well, this is going to go in for n, and then we'll be left with numbers everywhere except for t1, and we can solve for t1. What are we going to get here? We're going to have Sn, which is 10,940, equals t1, which we don't know, times negative 3 to the 5 minus 1 over negative 3 minus 1. Now, I've made a mistake. And I'm not saying that like I just caught it. I intentionally made a mistake here. And it turns out that the mistake I made is still going to give me the right answer, but not always. Jay, you're nodding. Do you know what it is?
There should be a bracket around the negative 3 to the 5.
Right. And you don't mean this, right?
No.
Yeah. There should be brackets around the negative 3 that is raised to the 5. And the reason is that when you raise a negative base to an exponent, sometimes you get a positive result and sometimes you get a negative result, depending on whether the exponent's odd or even. Now, negative 3 quantity to the 5 means negative 3 times itself 5 times, which is going to give you negative, which you would get if you forgot the brackets. But if this was 4 or 6 or any even number, it wouldn't work. So simplify. I should have had a 1 there. 10,940 equals, well, figure out what negative 3 in brackets raised to the 5 minus 1 is. I want to say negative 244. So we have negative 244 over negative 4. Okay, this is going to be a recurring theme here in this course. Can I divide, am I allowed to divide negative 244 by negative 4? Am I allowed to do that? Well, yes, because negative 244 is in brackets multiplied by what's on the top. Okay, if, and this is a, remember, I'm teaching you math. We're learning about sequences and series right now, but I'm always teaching you math. Would I be allowed to, I don't know under what circumstances you would have this, would I be allowed to start canceling 4s out of the 244 and the 4 here? No, because that 244 on the top of what I've just written is not in brackets multiplying by everything else. That is so crucial in algebra. In other words, everybody, this is 21x. However, this is not 21 plus x. You can't do that. You can't start dividing stuff, as my grandma used to say, willy-nilly, just picking some numbers and just, oh, let's divide those numbers. You can only divide things that are factors. That's an idea that's everywhere in Math 20 and Math 30 and beyond. Okay, so we are allowed to simplify that. 244 divided by 4, negative over negative is positive. I want to say that's 61. Okay, so what we end up with is 10940 equals T1 times 61, which means the first term is whatever this is equal to. And I don't think that simplifies. I don't see how it could. unless it goes in there 20 or 30 times or something to give you that 0 at the end. I don't even think it reduces down because 61, I believe, is a prime number. That's it. That's the first term. And as much as I talk about fractions and showing your work and all that and understanding the math, there comes a time in everybody's life where you just want to know what the answer is. Because I could ask you this in a numerical response question. The first term rounded to the nearest whole number is blank, 179. That's it. I believe you have close to a half hour left to practice some of these problems. The assigned problems are on the textbook, page 53, number 2 through 9.